Hello guys, welcome back to TechDose, and in this video we will see the airplane seat assignment probability problem, which is from Leetcode number 1227, and this is based on maths probability, and we will show you the proof of the entire solution at the end of the video. So let's first look at the problem statement. In this problem, n passenger board an airplane with exactly n number of seats. The first passenger has lost the ticket and picks a seat randomly, but after that the rest of the passengers will take their own seat if it is still available and pick other seat randomly when they find their seat occupied. Okay. Now we need to return the probability that the nth person gets his own seat, right? So let's look at an example for better understanding. Now in this case, you are given n number of passengers and you have n number of seats. There are two conditions. The first condition is the first passenger has actually lost the ticket and takes the random seat, but all the other n-1 passengers have their own ticket. Okay. Now the other passengers will take their own seat if it is available because they have the ticket, so they know which seat to take. Otherwise they will take any random available seat if their seat is already occupied by someone else. Now our goal is to find the probability of the nth person getting his correct seat. Okay, now if let's say you have just one person and one seat, then even though he loses the ticket, he will always get his correct seat because there is nobody else present, right? So the probability of getting the seat, that means the correct seat, will always be 1. That means 100% chance. But if you have two passengers, then what is the probability that the second passenger will get his correct seat? Now in this case, if you check it out, the first passenger may get his correct seat by choosing randomly, or he may not get his correct seat. So there are two cases. If the first passenger gets his correct seat, the second passenger will also get its correct seat, right? Otherwise, if the first passenger gets a wrong seat, then the second one will only be left by one option, which will always be wrong, isn't it? Therefore, if you have two seats, there will be 50% chance of getting the correct seat depending on if the first person has actually got the correct seat. Okay. So the n equals to 1 value is a base case and all the other values can be generalized. So if we see about the cases, then for the first person there can be two cases. The first case is the first person may get the correct seat by randomly choosing, right? So if there are n number of seats, then the first person will have n number of choices, and out of all those choices only one option is correct. Otherwise all the n-1 options are wrong. So the chances of the first person by choosing randomly among n seats to get the correct seat will be 1 by n, and the chances for the first person to get a wrong assignment is n-1 by n, because all the other n-1 seats are not the correct seat for the first person, right? So in case number 1, everyone gets their assigned seats. Therefore, the nth person will always find its assigned seat, because if you read the problem statement, then all the other passengers except for the first one will always take their correct seat if it is available, right? So if the first passenger has taken its correct seat, then all the other passengers will keep on picking their own correct seat, and the nth passenger will always pick the correct seat. So if case 1 happens, then you will have 100% chance that the nth person will get his correct seat, right? So this is easy to solve. And if you think about the case 2, then if the first person gets a wrong assignment, then we have to continuously keep on checking what happens with the second person, third person, and so on till the nth person. Okay, so let's see how to solve case number 2. If first person don't get his seat, then he must not take nth person's seat, and this must always be true, because what we want to calculate is probability of nth person to get his correct assignment. Let's see a seating assignment for 6 people. So I have already written the correct seat for 6 people. That means seat number 0 should go to P3, that means person number 3. Seat number 1, that means index 1, should go to person number 6, and so on, right? So who is the last person in this case? Now since the first person is P1, the last person is P6. So P6's correct seat is seat number 1. Okay, that means this is the nth person's seat. And if you look at the first person's correct seat, then this is index number 4, right? Now since we are calculating the chance that I don't care about what kind of assignment you guys are doing, but then the sixth person, that means the nth person, should be sitting at its correct place, right? And if that has to happen, then the first person, if he doesn't get his correct seat, okay, like if P1 does not get index number 4 seat, then he must not get index number 1, because if P1 fills index number 1, then definitely P6 will not get index number 1 seat, which is its correct seat, right? So in this case, the probability will become 0, right? So I am just adding up all the chances which will lead to the nth person getting its correct seat, okay, and just add them together to get the final probability, right? So in this case, the available number of options will be n minus 2 for the first person, because if the first person do not get his correct seat, then he can also not take the nth person seat, right? So how many options do he have? Initially you have a number of seats, so 2 options are removed, so the total number of options will be n minus 2, and the chance of any seat getting assigned out of these n minus 2 seats will be n minus 2 by total number of seats, n minus 2 by n, okay? So let's see a dry run and understand how the probability calculation actually works here. I would like to announce about our live training programs, data structures and algorithms, which is interview dose, and system design, which is design dose. If you are looking for making a switch from service to product based, or even make a product based to product based top tier switch and aiming for your dream company, this is the best curriculum you can ever join. I'll be your mentor throughout the cohort, and I will help you clear all your doubts in the one-on-one sessions. You can know more about this by querying us on the WhatsApp number, or you can also visit our website techdose.co.in. Now let's say that we are assigning the seat for the first person. So for the first person, we will be randomly assigning the seat. So what will be the probability for the first person? Let's say that we number it as probability of 1, okay? And if the first person gets assigned index number 4, then definitely the nth person will get index number 1, because everyone else will get their correct seat. P2 will get 2, P5 will get 3, P4 will get 5, and so on. So what is the chance of P1 getting index number 4 out of all the available options? It will be 1 by n, which is 1 by 6 in this case, since we have 6 people, right? And then we will be adding up. So this is for case number 1. Now we need to check for the case number 2, where it says that the person 1 will not get the correct seat. Okay, so if person 1 do not get the correct seat, then we know that in order for nth person to get its correct seat, the first person should also not get the nth person seat as well, right? So the first person is left with n minus 2 choices, and n is equals to 6. So we have 4 choices for the first person. So 4 out of 6 will be the probability in this case, right? So the chance of getting either index 0, 2, 3, 5 out of all the 6 options will be 4 by 6. Okay. Now P1 can be assigned anywhere. Let's say that P1 is assigned here, right? Then after this assignment, we will have to check the probability of assigning person 2. Okay, so let's calculate it separately. Probability of assigning person 2 so that the nth person, that means the 6th person, get its correct slot will be equals to, now the second person will check if its slot is empty or not empty, right? One case could have been that P1 was not present here and P1 was assigned somewhere here, because it is a random assignment. So in that case, all the people from P1 in between P1 and P4 will actually get their correct assignment, because you see that P2 will come and see its correct index 2 is empty, so it will come and sit here. Again P3 will come and see that 0 is empty, so P3 will sit here, right? Now P4 will come and see that its seat is not empty, so P4 will start searching randomly for some other space from whatever space it is available, right? So the sub problem will be reduced. Okay, so we are trying to take the largest size of the sub problem. If P1 is assigned to P4, then P2, P3 is not involved in the sub problem itself. Okay, so just to make a larger sub problem, let's assign P1 to just the next person's seat, which is at index 2. Okay, now we are calculating for P2. Now P1 is sitting at the P2's correct seat. Now P2 is coming. Now if we assign P2 at P1 seat, then you know what, after this the nth person will absolutely 100% guaranteed he will get seat number 1. That means his correct seat. Why is that happening? Because we are breaking the cycle here. You see that P1 was not getting its correct seat, and in place of P1's correct seat, P2 is coming, and in place of P2's correct seat, P1 is coming. So now everything has been cancelled out, the cycle has been broken, and now from P3, P4, P5, P6, everyone will get their correct seat according to the question's second condition and the first condition as well, right? So if this has to happen, if we need to guarantee this, then what is the chance that P2 gets P1's space here? What is the chance of this? It will be equals to 1 by how many seats are available? There are 5 seats available because P1 has already occupied seat number 2. So 1 by 5 plus, let's say if P2 does not get a P1 seat, that means index number 4, P2 does not get it, then he can also not take the nth person seat, because if P2 takes nth person seat, then how will nth person get his seat, right? And what are the available options for P2 now? 0, 3 and 5. So 3 options out of 5 options, because we are not counting index number 2 since it is already occupied. It is not an option. So you need to multiply it with the probability of the third person assignment. So let's assign it in such a way that the sub problem size is as large as possible. So I will be assigning it to P2. I hope you have understood why I am assigning P2 to index number 0. If I give it to, let's say, index number 5, then P3 will get its exact correct seat, and that will not contribute to the sub problem. Okay. So let's come to for person 3. Let's solve it. Similarly for person 3. Now he cannot get his correct seat, right? Now if in order to break the cycle, he should get the correct seat of P1 to break the cycle, right? Because P1 occupied P2 seat, P2 occupied P3 seat. If P3 occupies P1 seat, then it will be breaking the cycle, like P1 occupying P2's, P2 is occupying P3's, and if P3 is occupying the seat of P1, then it will be breaking the cycle will be done. Okay. And everyone else outside of the cycle will definitely get their correct seat. Now in this case, what is the chance that P3 gets index number 4? You have just one slot out of 1, 2, 3, 4 available slots, right? So 1 by 4 is the chance. But then if P3 doesn't get this index number 4, then what then? Then our cycle will continuously keep on enlarging, right? It will not break, it will not form a cycle, it will increase. So what are the other options? Now it cannot get P6, otherwise the nth person cannot sit at its correct place, and also it cannot get index number 0, 2. Okay, so the only available options are 3 and 5. So 2 options out of 4 options. Okay, and then you will be multiplying it with the probability for assigning the 4th person. So let's assign the 4th person. Now I hope you have understood this. Let's first assign this P3 at this P4 in order to get the maximum size of the sub problem. Now P4 can actually break the cycle by going to the correct position of P1, and that chance is 1 by 3, because this is one slot and you just have 3 slots open, index 1, 3, 4. Plus if he doesn't get this slot number 4, then how many slots are available? Only 3 is available, because 1 cannot be taken. It has to be taken only by the last person. So 1 out of 3 options are available. And we are done assigning for person number 4. Let's assign him here to increase the size of the sub problem, and let's make the assignment for person number 5. In order to complete the cycle, person number 5 should go to P1, because what is the graph that we are forming now? P3 is sitting at P4's place and P4 is sitting at P5's place, right? Now if P5's happen to sit at P1's place, then you form a cycle, and everyone after this will definitely sit at its correct position. Now what is the chance that P5 sits at P1's place, that is index 4? It is 1 by, you just have 2 empty slots, index 4 and index 1, right? And if he doesn't get this, then he cannot sit at index number 1, so he do not have any other option, so the probability will be 0 in this case. 1 is not an option for this 5th person. Okay, so if you add up these all probabilities, then you will get the chance that person 6 will sit at its first position. and let's calculate what is the probability coming. Now you can always reverse calculate the entire probability. Okay, so if you replace this 1 by 2 here, then this becomes 1 by 6 plus 1 by 3, which becomes equals to 1 by 2. Now again, if you replace this PR4 here with 1 by 2 value, then this 2 and 2 will get cancelled out, and 1 by 4 plus 1 by 4 becomes 1 by 2. Again, PR3, if you replace it with 1 by 2 simply, then it will again be equals to 1 by 2. Now again, if you replace this PR2 with 1 by 2, then again you calculate it, it will again become 1 by 2. Okay, so this will become 1 by 2 again. So the entire probability answer is 1 by 2, and no matter what is the size of problem, if n is greater than 1, your probability of nth person getting to his correct seat will always be 1 by 2. Okay, that is the statement, and let's see the proof of this. Now we will be trying to prove it by induction. If you just have a single person, he will always get his correct seat. If you have more than one person, then the last person's probability of getting correct seat will always be 1 by 2, no matter the size of the problem. So how to prove it? Now in induction proof, we always assume that the nth step is correct, and we try to prove it for n plus 1th step. So let's assume that probability of the nth person, where n number of passengers and n number of seats are available, the probability of nth person to get to his correct seat is 1 by 2, according to whatever statement that we have made. Okay, according to our hypothesis. Now we need to prove that probability when you have n plus 1 passengers and n plus 1 seat is also 1 by 2, right? So let's write it. Probability with n plus 1 people and n plus 1 seat is equals to, if the first person gets to his correct position, if you have total of n plus 1 seat from 0 to let's say n, then if P1 had to sit at some ith index, and if he gets to his correct seat, then everyone else will always get to his correct seat according to case number 1. So what is the chance of getting this done? It will be 1 by n plus 1, and this is according to case number 1 that I had explained. Okay, now if P1 do not get to his correct position, then what happens? Let's say that Pn's, that means Pn plus 1, who is the last person, his index is let's say index number j. So if P1 cannot get to his correct index I, he should not get to index number j, because that is reserved for the last person, right? So how many options does he have? Out of n plus 1 options, he has, I mean 2 options are removed, his correct one and the last person's correct index. So n plus 1 minus 2 by n plus 1, because you have total of n plus 1 slots available, right? So this will be boiling down to n minus 1 by n plus 1. Okay, now this is the assignment for the first person, and when the first person has been assigned, then you need to assign for the second person. So in this case, the size of the sub problem will reduce by 1, and next time you need to calculate for Pn. But we have already assumed that if we have n people and n seats, then my probability is 1 by 2. So I can simply replace it, and I can write it as 1 by n plus 1 plus n minus 1 by n plus 1 into 1 by 2. Okay, now if you take the LCM, then it will be 2 times of n plus 1, and this will be 2 plus n minus 1, and this will be equals to n plus 1 by 2 times of n plus 1, and you know this n plus 1 will get cancelled out, and this will be 1 by 2. So we have proved that P of n plus 1, that means even if we have n plus 1 passengers with n plus 1 seat, we get the same probability of 1 by 2. So we have proved the entire hypothesis by using proof by induction. Okay, so if you know this proof, then the code becomes very simple. Without the proof, if you solve it by recursion, the time complexity will be order of n, because every step you are doing one step after another. But after the proof, you can simply write if else statement and return, if n is 1, then return 1, otherwise you return 0.5. So let's look at both the codes. Now this code is very simple. The first one is a recursive code where you are given n, and if n value is 1, return probability as 1. Otherwise, the first condition is if the given person Pi sits at its correct index, let's say index number j is sitting at its correct index. If that happens, then what is the chance of that happening? you have n number of slots, and out of that only you have one correct seat, so that will always be 1 by n, where n is the number of available seats currently. Otherwise, if that doesn't happen, then if pi does not get his correct seat, then what else can he get? Now if he doesn't get his correct seat, then he should not get the seat which is reserved for the nth person, right? Because the nth person has to sit there. So how many available options does he have? 2 options are removed out of n options, so it will be n minus 2 by n. Okay, so this is neither first nor the last. Okay, now once you have calculated them both, then you need to add up the conditions like break cycle, right? If the current item is getting to its correct position, plus he has to take any random seat other than the last person's seat and his own seat, right? And that multiplied by you need to solve for the other people's assignment. You have to multiply, because why you have to multiply is, in probability you always have to multiply whenever multiple conditions have to come together. Like let's say if condition 1 and condition 2 and condition 3, all these conditions should happen to together to get to your final answer. Then if you want to find out the chance of this happening, all the conditions happening together, you have to check the probability of getting the condition 1 and the probability of getting condition 2 and probability of getting condition 3. You multiply them together and then only you can get to the final answer, right? That's it for the recursion solution. In the proof by induction solution, you know that if n is 1, then you need to return the value of n, that means 1. Otherwise, you need to return 0.5. So that's it for the problem. I think this problem was not very intuitive, and that's why we took a lot of time explaining it. I hope you were able to understand it. If you have any question, please comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.